All right, on page 12, number 78. So bus drivers at the Bloodhound Bus Company believe that in the past they load an average of 24.5 bags per bus trip. A random sample of 10 days finds an average of 27 with a standard deviation of 3.5 bags. And they want to know, is this sufficient evidence to suggest the number of bags has increased, given the level of significance at 0.05? And we get to assume the conditions have been met. So let's see, we want to find sufficient evidence that the number of bags have increased. So if we go through our hypothesis test, the null hypothesis, we have to assume that the mean is going to be 24.5, what they claim to be. But the alternative, we're trying to show that the number of bags have increased, so the mean is going to be greater than 24.5. So typing that into that same menu, we're going to go to stat test, and we're going to do a t-test because this is based off means. And I have the stats. The hypothesized value is 24.5. The mean from our sample was 27 with a standard deviation of 3.5, and the sample is 10 days. And our alternative we are trying to show is that the number of bags have increased. So typing that in, I get a p-value of 0.025, and since that's less than or equal to alpha 0.05, that means that we do have sufficient evidence to reject the null hypothesis. So in this problem, let's see, we have p is less than alpha, so I'm going to get rid of a and b, and that means you have sufficient evidence of the increase. So you're able to reject the null. Okay, 79. An IRS report claims that a 90% confidence interval for the mean hourly wage of persons under the age of 23 who are attending school full-time is given. Which of the following null hypothesis statements would you be able to reject using this interval? So remember, guys, if the null hypothesized value is within the confidence interval, we have to assume that it's a reasonable value for the problem. So you have to assume it's true. But if it's outside of the confidence interval, then we can say that we have enough evidence to say that the alternative might be in favor, okay? So you want to reject, which means we don't want it in the interval. So not within the interval. Okay, because that means we have enough evidence to say it wasn't that value. So let's see, 13 is within that, 12 is within it, so is 11. The only one that's not is letter D. Number 80, for a random sample from a skewed population, for which of the following sample sizes would the sampling distribution of X bar be approximately normal in shape? Remember, to be approximately normal in shape for a mean problem, you just need the sample size sufficiently large, which is anything greater than or equal to 30. That's going to be letter B. 81, two confidence interval estimates from the same sample are given, okay? Which interval and reasoning would support a decision to fail to reject the null hypothesis? So that means it must be within. It must be within interval. And what I'm talking about, what must be within, is the null hypothesized value. So the only one that the null hypothesis is in is the second interval of 71.3 to 78.7. So I'm going to get rid of A and B. And the reason is because 72 is within the interval. Okay, so if you fail to reject it, that means it's a reasonable value. So it has to be inside the interval. Okay, the next two questions, we're going to use the greatest internet company claims its internet speed will have upload speeds faster than any other internet provider on the market. To determine whether greatest claim is valid, 30 internet users are assigned to two groups. The subjects in one group are given greatest internet, and the subjects in another group are given internet from the simple internet company. The number of minutes required for each subject to upload an online file is recorded. So they kind of organize this in a nice little table for us. So they want to know, what are the appropriate hypotheses for this test? Well, remember, when you're comparing two means or even two proportions in a hypothesis test, you have to assume that the means will equal each other in the null hypothesis. So the only one that allows us to get rid of is letter D, right? Because all the rest are assuming the means would equal. But in this case, we are trying to show, so we're trying to determine whether greatest claim is valid. So they're trying to say that their upload speeds are faster. So we want their time to be faster. And think about faster. Faster means less time. So we want the mean of greatest internet company to be less than the mean of simple internet company. Okay, so think about that logically. If you want it faster, you want less time. And to finish that problem set up, number 83, which of the following is the most appropriate conclusion? So we need to figure out if we're going to reject or fail to reject HO. I'm going to go ahead and get rid of letter B. You'll never accept the null hypothesis. So that's not even an option. So let's see, if I do a hypothesis test with this is going to be a slightly different menu that you'll go to. So instead of going to stat, test, t-test, now you need to go down to where it says that you have a 2-sample t-test. Now you have 2 samples, but you're still doing a t-test. So number 4. I have the stats, right? You have to pay attention to which one's listed first. So since the greatest internet company is listed first, this is going to be my X bar 1 and my SX1. Okay, so 8.4 and 4.23. And that sample size was 15. And then this will be my X bar 2 and SX2. So 8.9 and 4.61 with a sample size of 15. And we want to show that greatest is less than the simple internet company. Remember, pooled, you guys don't ever have to change that. We'll always just leave it as no. So if I hit calculate, let's see what I get. So I get a p-value of 0.380 technically with rounding. And remember, we compare that to the alpha of 0.05. So in this case, we're greater than alpha. So remember, if you're greater than alpha, we're going to fail to reject HO. So A is out. And when you fail to reject HO, that means you did not have enough evidence for HA to say that greatest was faster. Okay. Okay, number 84. You find the line of best fit for a set of data and calculate the correlation coefficient for the model is negative 0.34. So which statement best describes the fit of the model to the data? So this is our very last unit we just got done covering. So first of all, remember, if it's negative, that means you have a negative correlation. So I'm going to get rid of the 2 with positive. Remember 0.34. 0.34 is in between point for your moderate to strong. So remember, strong is 0.8 to 1. 0.5 to 0.8 is moderate. And 0 to 0.5 is going to be weak. So this would be a weak negative correlation. So it's not a good fit for the data. So remember, 0 to 0.5 either way is going to be weak. 0.5 to 0.8 is moderate. And then 0.8 to 1 is strong. And it does the same exact thing going the other way. So, okay, we definitely don't have time for the next one, so I'm going to stop the video there, and then we'll pick up with 85, and then we'll actually probably get through the multiple choice in that last video, and then we'll start on the short answer of your review. So even though your review is going to be all multiple choice, I would still practice the short answer because some of the concepts in the short answer aren't in the multiple choice. That's why they're on there. So, all right, see you guys next time.